Hello everybody and welcome to your lecture number 3 for Earth Sciences. We're going to go over latitude and longitude today. This is your global geography lecture, so something that maybe you heard about in middle school or high school, but we're going to do a refresher on that because it comes up a lot in future lectures. I'm going to refer constantly to this latitude, that latitude. You got to know what I'm talking about. Also, we're going to get into a little bit of Earth-Sun geometry. We're going to learn a little bit about where the seasons come from, about some of those special latitude lines like the Tropic of Cancer, Tropic of Capricorn, kind of why those things exist, what they mean. And anyway, that's what we're going to be covering today. So we are going to start this lecture right now. I don't want to keep you waiting, and we'll go right into the material. And we're going to start off with, of course, latitude and longitude. And of course, I have my nice little globe here to demonstrate some of these things. But you know that if you look at a globe, and hopefully you've seen one of these things before. I kind of like this one. I got to fix this wire here. I like this one because, and I can actually pop this up a little bit larger so you can see it. If you look at, I like this one because it glows. It's actually a light. So make a nice night light in your room if you want. But anyway, this has got, of course, if you looked at this, lines on it of latitude and longitude, right? And the reason that we put those lines on there is because, we have to talk about exact places on the surface of the Earth. And it's hard to make a nice grid like we're used to on a sphere, right? Of course, the Earth is a sphere. So, roughly a sphere. But how do we do that? Well, we use latitude and longitude to make that nice grid so that we can have a very exact place, point out a very exact place where we're referring to on the surface of the Earth. So in order to locate very specific locations on Earth's surface, that's why we divide everything up to a grid. I got to turn my pen on here. It always kind of doesn't always work. There we go. Okay. So now the north to south divisions are called longitude. So if I get my globe out, great, here's the North Pole. Here's the South Pole down here. The lines that go from pole to pole, they connect one pole to the next. Those are lines of longitude, and we have special names for those. Those are called meridians, okay? So the lines that divide up Earth and extend from one pole to the other are called meridians, okay? Those are lines of longitude, but the proper name for lines of longitude is meridian, okay? So we have the meridians. Then we have other lines that are actually circles, okay? So we have one type of line there called meridians. They go from one pole to the other, right? And they actually make, if you think about it, a half circle, okay? Because they go from one pole to the other, and that's a half of a circle. We have other lines that are full circles. They go around, and they kind of surround each of the poles. So they go like this, right? And those lines are called parallels. That's a great name for them because they are, in fact, parallel. They don't touch. So the east-west divisions, the lines of latitude, okay, those are called parallels. So lines of longitude are called meridians. Lines of latitude are called parallels, okay? So here's a picture of different lines of latitude, okay? So they're shown in the red, right? Those are lines of latitude. They're called parallels. And these lines that are shown in red here are the lines of longitude. Those are called meridians. Okay, they go from pole to pole. So you'll notice that on your lecture assignment, you have to, one of the kind of more difficult questions is you have to draw in some lines of latitude, some lines of longitude. And you have to remember that when we're talking about meridians and lines of longitude, every single line you draw has to go from one pole to the other. Okay, they start at the South Pole, end at the North Pole, or vice versa. Okay, so now parallels can be anywhere from 0 to 90 degrees north or south. So you might be wondering, what the heck am I talking about there? For every line of latitude, for every parallel, we give it a number. All right, so those lines go from 0 to 90. Okay, so we go here. This one would be, I guess this would be 15, and then 30. 45, 60, and then I guess this would be 75, and then there, the North Pole, that's 90 degrees. So Santa Claus lives at the North Pole 90 degrees north, okay? Now notice that we go in the other direction, go south, it's the same pattern, right? You go 15, then 30, then this would be, I guess, 45 south, okay, 60 south, 90 south, and that would be the South Pole, okay? So the penguins live in the Antarctic, that's South Pole, 90 degrees south, okay? Now, lines of longitude, the meridians are different. Notice that you can have anything from 0, we give it a number, it goes anywhere from 0 to 180, all right? And that kind of makes sense if you think about it, because remember, there's 180 different meridians, there's 90 different lines of latitude, and that kind of makes sense because remember that the lines of latitude are full circles, whereas the lines of longitude, the meridians, are half circles. Okay, so it makes sense there's double the number of them. All right, so lines of longitude, meridians, go from 0 to 180. We have two hemispheres. Okay, so just like we have two hemispheres here with lines of latitude, the north and the south, we have two hemispheres here for longitude. We have the western hemisphere. You know, welcome to the Western Hemisphere. You're probably, I assume, in the Western Hemisphere right now, unless you're an international student, but all of America's in the Western Hemisphere. Or you have the Eastern Hemisphere, okay? So people in Europe, or most of the people in Europe, I should say, not Spain, but most of the people in Europe and, right, Asia, that's the Eastern Hemisphere. Most of Africa is in the Eastern Hemisphere, et cetera, okay? So, whereas the Americas, okay, North, South, Central America, those are entirely, or just about entirely, I guess I gotta be a little careful what I say, but almost entirely in the Western Hemisphere, okay? So, now when we divide up, of course, the meridians, we have a special meridian, okay, that represents 0. Now, that special meridian, it goes right through Greenwich, okay? So here's my beautiful globe, and right through Greenwich, we're going to go from the North Pole through Greenwich to the South Pole, and that's the prime meridian, okay? So you can see it going right here, goes through Greenwich, England, right? Which is very close to London, and it passes through Africa, okay, West Africa, passes through France and parts of Europe. Okay, so there's the prime meridian. Prime meridian is the 0 degree meridian. Okay, the 0 degree meridian. Now, for the lines of latitude, right, we have a kind of base 0 degree reference line of latitude, parallel, and that goes through the fattest part of the Earth. That's the equator. So it goes right, the fattest part of the Earth, right here. That's the equator, and you can see that it goes through Brazil, goes through Colombia, goes through the Congo in Africa, and Indonesia. Okay, so there's your equator. Okay, fattest part, that's 0 degrees north, 0 degrees south. Actually, we don't even put the north-south, okay, because it's 0 degrees. That's the parallel. That's like the reference parallel for the Earth. Okay. So just notice here how parallels, this is a picture of the Earth with all the parallels on it. Notice how the parallels are circles. I guess the only one that's not a circle is the North and South Pole, and those are actually points. They're just single points rather than a circle. So it's kind of cool because when you say 90 degrees north or 90 degrees south, that tells you an exact point on the surface of the Earth. Usually you need two numbers, right? You need to tell me the latitude and the longitude, but in this case, I only need to tell you the latitude in order to know exactly where you are on Earth. 90 degrees north, 90 degrees south. It's the only place where latitude is just a point and not a circle, okay? So circles that do not cut the Earth into two equal halves we call small circles. So I want you to notice that if we were to cut the Earth, now here's another thing, basic geometry. Whenever you cut a sphere, you always produce a circle. Okay, so the cut that you make is a circle. Whenever you cut the Earth, you're going to produce a circle. Those circles are either small circles or great circles. Small circles are circles that do not cut the Earth into two equal halves. Great circles cut the Earth into two equal halves. Okay, the only parallel, notice that the only parallel that is a great circle is the equator, which would be right here. This is actually the equator down here, okay? So that is the only parallel that cuts the Earth into two equal halves, and that would be the Great Circle. Every other circle here, these are all small circles, okay? So these are all small, 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 but the equator would be great. On the other hand, if you were to think about this, every single meridian goes from pole to pole, lies along a great circle. Now, why didn't I say that every meridian is a great circle? I didn't say that because it's not true. Meridians are not great circles because they're not circles, right? They lie along great circles, but they're not great circles in themselves because they're not circles. They're semicircles. They go from pole to pole. Okay? If it was a real circle, it would go from the North Pole all the way around to the North Pole, which it doesn't do that. Okay? So that's the difference between great circles. So you have a question, I think number 11, which is kind of the challenge question, but it's at the bottom of your page. And it wants you to, I think it says, yeah, which of those circles are great circles? So you have to tell me which of the circles we talk about there in that question are great circles. That's how you know that. Okay. So notice that meridians are not circles. They're half circles, but they lie along great circles. Every meridian starts at one pole, ends at the other. Every meridian combined with its opposite is a great circle. What do I mean by that? That means if I were to take, oh, by the way, look at this picture. This is a good one for number 2, okay? You're looking at the Earth. In number 2, you're kind of looking at the Earth in a weird way that you're probably not used to, but you're looking down at the North Pole, and I'm trying to show you, I kind of like looking at the Earth this way when we're talking about meridians. So you're kind of looking at the North Pole down like that. I like to look at it this way because it shows you how the meridians radiate out from the poles, okay? So when you have this sort of view looking down at the North Pole, you see that the line that goes through Greenwich, England, there's Greenwich right there, okay? The line that goes, the meridian that goes through Greenwich has to be the prime meridian. It has to be the prime meridian. So I'm going to draw that one, okay, highlight that, that's the prime meridian. Then we have a line that makes a 90-degree angle with that. We actually have two lines that make a 90-degree angle with that, okay? One that goes to the east, and that becomes 90 degrees east, and another that goes to the west, that's 90 degrees west. Notice we have also another one that goes like this, okay? These are all on number 2, and this is a 180-degree angle, and therefore back here this is 180 degrees. Notice we don't say east or west when we talk about 180 because you'll notice that there's only 180-degree meridian, okay? Everything else, like if you take like 150 degrees, you have to say whether it's east or west. See how there's a 150 east and a 150 west? You have to tell me if it's 150 west or 150 east because there are two of them. There's two 150s, so you have to tell me which one you mean, east or west. You don't have to do that with 180, and you don't have to do that with the prime meridian because there's only one prime meridian, okay? I'm going to skip this part. Okay, but anyway, hopefully you've gotten everything you need now all the way down. Probably you've actually gotten almost everything you need all the way down to number 11 on the first page. Okay, there's a little bit there that we're going to go over later, but this is just a good kind of page to review. So I want to talk a little bit now about the seasons. Okay, so the seasons have a lot to do, and actually I should say this whole scheme of latitude and longitude is actually kind of related to the seasons. So I want to talk about how all the seasons and the Earth-Sun geometry kind of fold into this. Okay, first of all, seasons are not really kind of arbitrary made-up things. They actually have something, they're sort of like mathematically established in Earth-Sun geometry, okay? So there's a very specific day, it's the first day of summer, and it's not as if we all just got together and said, hey, we're going to have June 21st or 22nd be the first day of summer. That's not really how it works. There's actually a very specific geometry that occurs at that first day of summer, first day of winter, fall and spring. Okay, so we're going to go over that geometry. It's very important for understanding the Earth and the seasons and a lot of other things, weather and climate, as we start to get into those later in this course. Okay, so as you can see, you have, I don't know where it is. I guess it's probably, no, it's up there. Yeah, up there. You probably see the Earth spinning around the sun there. And I want you to notice one thing about the Earth revolving around the sun. Notice how its rotational axis always points in the same direction? So, you know, as the Earth goes around the sun, it's never going to change that direction that its axis is pointing in. Also notice something else. That axis, you've probably seen, you know, the globe look like this before. You notice that it's tilted. So there it goes. It's rotating on its axis, but its axis is actually tilted relative to its orbital plane. So that's the plane in which the Earth orbits around the sun. That tilt is very important. That's what creates the seasons for us. So that tilt is a very important number. Memorize this number, underline it. It's going to be on the tests, both final, midterm, etc. It's 23.5 degrees, okay? And that actually changes over Earth's history. It hasn't always been 23.5 degrees. It actually goes sometimes 22, all the way down up to 24.5. So it fluctuates. Right now it's about 23.5. All right, so this creates 4 special positions. And those positions are going to be the autumn. They're going to correspond to the autumnal equinox, the vernal equinox, the winter solstice, and the summer solstice. Okay, so let's go over each of these. Okay, so this is a picture of how the sun's rays strike the Earth during the summer solstice. So notice that the Earth's rays are coming in, they're all parallel, right? They're all coming in like this, parallel. Notice that they strike the Earth at different angles. Here at the North Pole, it's striking the Earth at a very low angle. Okay, so you have that angle, which is, I don't know, I guess that's actually about 23 degrees, actually. 23.5 degrees, as a matter of fact. You know, here at this line of latitude, it's striking at a larger angle. I don't know what that is. Maybe it's, I don't know, 35 something. I'm just making a number up. You know, here it's striking at a larger angle. Okay, so now that angle right there I'm drawing, that's like, I don't know what that is. That's maybe like 75 degrees. And then notice that right here, it's striking at about a 90 degree angle, right? Actually, it's striking at exactly a 90 degree angle. But notice that where the sun's rays are striking at a 90 degree angle, that means the sun is directly overhead at noon, directly overhead. That is not at the equator. The equator is right here. This is the equator. Okay. So at the summer solstice, the point at which the sun is directly overhead is actually at this line right here. Okay, and that line is actually called, we have a special name for that, it's called the Tropic of Cancer. And the Tropic of Cancer, the actual latitude of the Tropic of Cancer is a very special number. It is 23.5 degrees north. There's one in the south that's called the Tropic of Capricorn. That's the 23.5 degree south line. Where have we heard that number before? It is, as you know, the tilt of the Earth. Okay, it's the tilt of the Earth's axis. So relative to the ecliptic plane, relative to the plane which Earth orbits in. Okay, so those lines, they're not just made up. It's not like somebody just looked at Earth and said, hey, you know what? It's hot here, so we're going to call this the tropics, and it's going to be between, 23.5, 23.5 north-south. Okay, that's going to be the tropics. That's the hot place. No. It has everything to do with geometry, right? The Tropic of Cancer is where the sun is directly overhead at summer solstice. Guess where it is at winter solstice? It's over, okay, I guess I don't have it here, but it's over the Tropic of Capricorn. Okay, so it would be over this line right here. Okay, so that's where the sun's going to be 90 degrees directly overhead during the winter solstice. Okay? So that's why we have the tropics. So the sun is going to migrate between where the sun is directly overhead. By the way, we have a special name for that. It's called the subsolar point. I don't have a question about the subsolar point, but it's a really good thing to just write down on your lecture assignment and remember what this means. It's the latitude at which the sun is directly overhead. Okay, so the subsolar point migrates annually between 23.5 degrees north, 23.5 degrees south, between the tropics. Okay, now on the vernal equinox, it's going to be directly above the subsolar point. Is going to be at the equator, and at the autumnal equinox, first day of fall, it's going to be directly above the equator again. Okay. So that's how that all works, okay? Now, the Antarctic and Arctic Circle, you probably heard of those things before, okay? That's where, of course, the temperatures are very cold. 66.5 degrees north and south. So what you'll notice, actually, you see this line right here. This is where the sun... I'm going to erase everything on here so you can see this more clearly. Notice that where the sun's rays come in, and it's like, whoops, it's basically like the very top of the Earth. Okay, right here in this drawing, that's the very top of the Earth. That's the very top. Notice it's not the axis, not the North Pole or South Pole. It's actually right here, draw this, it's actually the Arctic Circle and the Antarctic Circle, okay? And guess what, 66.5 degrees north and south. Where do we get that number? It's just 90 degrees minus 23.5 degrees. And that equals 66.5 degrees. Okay? In the Arctic and Antarctic Circle, there's going to be at least 1 day per year in which the sun does not come up and the sun does not go down. So you've probably seen videos. Let me show you a video about this because it's pretty, they're pretty cool. Whoops, that's my email, sorry. Let's show, I want to show you this. So this would be Midnight Sun. I have to be careful because there's like vampire movie called The Midnight Sun. Midnight Sun time lapse, I'll put that in. And I like the one that's in Poland, actually. Okay, so I want to show you, this one's really cool. So whenever you're within the Arctic or Antarctic Circle, you're going to have a situation where the sun either doesn't come up all day or the sun doesn't go down all day. Notice this is at 77 degrees north. It's in Poland, in the Arctic Research Station in Poland. And the sun is going down. This is during the summertime. Okay, so the sun is not going to go down. You notice that it starts to go down, starting to make long shadows. It's getting near the horizon, and that looks like it's going to be sunset, right? But instead of going all the way down, it starts coming up again, and then we fade directly into the dawn. Okay, so that's we call this the land of the midnight sun. So you might know people that have lived in Alaska or something like that. They live within the Arctic Circle or the Antarctic Circle, and they have to get like blinders put on their windows and curtains at night because otherwise you're going to have a lot of trouble sleeping, right? Because the sun doesn't go down. And vice versa, if during the winter time the sun doesn't come up. If you're at the North Pole, the sun doesn't come up during the whole winter, during 6 months. So anyway, that's you're going to have at least 1 day within the Arctic in Antarctic circles where there's no sunlight or the sun doesn't go down. Okay, so high latitudes, we're going to define that as anything above 66.5 degrees, either north or south, right? 66.5 south. At high latitudes, you have cold climate, right? And notice that, by the way, that has nothing to do. A lot of people think weird things about why it's cold at high latitudes. It has nothing to do whatsoever with being like further away from the sun or closer to the sun. It has to do with the angle at which light is coming in. So notice that if you have a parcel of light coming in from the sun, that in the high latitudes it's striking the Earth at a very low angle. So if I have this amount of sunlight, that is spread out over this large area. Whereas if I have the same parcel of sunlight coming in, near the tropics or the equator, it's spread out over a much shorter area. So at higher latitudes, sunlight is dispersed over a larger area. It's kind of spread out and diluted. Whereas at lower latitudes, it's more concentrated. And that's why it's hotter at higher latitudes, hotter at lower latitudes. And that's why it's hotter during the summer than during the winter. It's because you're getting more direct sunlight. It's not because you're closer or further away from the sun. That has nothing to do with that. Okay, so anyway, there's your high latitudes. Here are your low latitudes. Low latitudes are going to be tropical. Okay, they start at 23.5 degrees north to 23.5 degrees south. Okay. All right. So going to move along here. Sorry. Now, mid-latitudes are shown here, okay? So this is going to be anywhere between 66.5 to 23.5 degrees north or south. So you are in the mid-latitudes probably right now. Most of America is in the mid-latitudes. And, a lot of the people in the world live at mid-latitudes, okay? So this is where you're going to have, your classic, traditional winter and summer, cold winter, hot summer, and kind of pleasant autumn, pleasant spring. Whereas if you're in the tropics, it's just hot all the time, right? So you don't get that effect. Okay. All right. So we covered really most of the things you need to know about in the lecture assignment. One thing that I want to point out to you. Whoops, sorry, brought that up. Sorry, I'm just checking this lecture assignment, make sure that I covered everything that I wanted to talk about. Yeah. There are a few, you can notice that like one of the last questions kind of has a map of the world for you. And I just want to make sure that, you're familiar with basic geography and where some big features are on the Earth, okay? So this kind of goes without saying, but obviously you should know the 7 continents. And you should know the 5 oceans. That's saying a lot of people don't know the 5 oceans. They know 3. They know Atlantic, Indian, Pacific, but they don't know the Arctic and the Southern. Okay, so the Arctic Ocean, the Southern Ocean are here. Okay. Also, some of the big mountain ranges, right? You should know some of the important mountain ranges on Earth. Right, the Andes Mountains here in South America. Okay, the Rocky Mountains most people know about here in North America. You might know the Appalachians, which are on the eastern side there. The Sierra Madres in Mexico. Okay, what are some other big ones? The Himalayas, right here in kind of northern India and China. And let's see, other ones I might talk about here: the Alps in Italy and Switzerland. I'm trying to think of other ones I might mention. Major deserts, that comes up sometimes. I don't know if I have any questions about deserts. Oh, I do. I did mention the Atacama Desert. So Atacama is right here in South America. Okay, next to the Andes Mountains. I'm trying to look at what major rivers of the world. Let me see if I have anything about major rivers, major lakes. Oh, I do want to point out, in case you don't know, some things I talk about here. Let me just go to this picture here. Hudson Bay is right here. Okay, that's that big bay that's in Canada. Okay, I'm sure you know the Gulf of Mexico, being, probably most of you living here in Corpus Christi know the Gulf of Mexico. Okay, but there are some things you might not know. The Philippines, okay, or the islands right here. Japan is right there, of course. Lake Baikal is a very important lake here in Siberia. Okay, there it is right there. And I'm just going through kind of pointing out certain things. This is Greenland. This is Iceland. What else? I think that might be it. Oh, I didn't hit the Aleutian Islands. The Aleutian Islands are these islands that come off the kind of look, you might have noticed there's like an arm that comes up off of Alaska. Those are the Aleutian Islands. Okay. All right. Well, I think I hit everything that I need to talk about today. So that'll be it. We went on just about 30 minutes. Please let me know if you have any questions, and you enjoy the rest of your day. Talk to you next time.